Number 5 here, this should be a pretty good quick one for us here. They give us the derivative. Just ignore all this stuff for number 6 there, but that was all my work for number 5. And so letter A is talking about Euler's method, starting at x equals 1, 2 equal steps, and now we got to go to 0. So since we're going from 1 to 0, 2 equal steps, that means that delta x has to be negative 0.5, because you're going to go 1, then you're going to go down to 0.5, and then down to 0. So since you're decreasing, that delta x would be a negative 0.5, and it gives us the initial starting point is the 1 comma 0, so I started with that. And then our delta x times the dy dx, so I got the negative 0.5, and then the dy dx, I got to take the 1 and 0, plug it into the first derivative right there. Now the derivative only has a y value. You're used to a lot of the derivatives from a long time ago only have x's, and you just use the x's, right? And sometimes they have x's and y's in it. This one just has a y in it. So that means just, hey, take the 0, plug it in there, you're going to get 1, and you get a negative 1/2, and then you go 0 plus the negative 0.5, get the negative 1/2 right there. And then that's your new y value, and then you're going to do your delta x again, which is a negative 0.5, and this time you got to take the 1/2 and the negative 1/2, plug it into that first derivative. So actually, you're just going to take the y value, plug it into that first derivative there. And so 1 minus the negative 1/2 would be 1 plus a positive, which would give us 1.5 right there. And then I came to the side and converted those into fractions. I like doing that without the calculator. So I got negative 3/4, and you got negative 50 cents, negative 75 cents, get that negative $1.25 right there. Euler's method, just like all the other Euler's methods that we've seen there. Now letter B, that letter C was pretty straightforward like we've been used to, but letter B, it was just a little bit different because you had to like do this other little weird thing at the end there. So let's kind of pay attention to that. Now they're asking us to do a limit. And when I plug in 1, f of 1, right? That's our limit technique. When I plug in 1 to the bottom, I'm going to get 0. When I plug in 1 to the top, I get f of 1, and they told us f of 1 was equal to 0. So I do have 0 over 0 format. And so make sure you write your limit notation. Put this is the limit as x approaches 1, and then you do the derivative of the top and the bottom there. Now, it's easy to take the 1 and plug it into that 3x squared part and get a 3 on the bottom, but let's be careful with the first derivative here. This is f prime of x. That's the same thing as dy dx at x equals 1. When you say f prime of 1, that's the derivative at x equals 1, right? But see, your derivative doesn't have any x's in it, so just like we talked about over here, you got to use the y value when that x is equal to 1. So then that's why so here's my derivative notation. And then, so instead of plugging in 1 anywhere, we got to use the y value of 0. So I'll just go 1 minus 0, which is equal to 1. That's how I'm getting a 1 for that. So all you want to know is what's the derivative at that point 1 comma 0. That's what you're asking. Since the derivative has a y in it, use the y variable. 1 minus 0 is going to give us 1. That's what the derivative is equal to. The same reason why I used the 1 right there, I just used the y variable there, right? So you're going to get 1/3 for that. And then letter C just says find the particular solution. So when you see find the particular solution to the differential equation, you're going to separate your variables, get the y's with the dy, x's with the dx, integrate both sides. Remember your plus c, then use a point that they give you to plug it in to figure out what that c value is. So I went to that first derivative. First thing you do is multiply both sides by the dx. Then you do legal algebra, get the y's with the dy, any extra numbers or x's with the dx, right? So I just divided both sides by the 1 minus y. Be careful when you integrate this. Remember, your u is that denominator. The du is equal to a -1. So you do have a 1 over u. So when you integrate 1 over u, you're going to get the ln of that thing. But your du is a -1. So you got to make sure you're careful with your balancing and balance that negative right there. Integral 1 is just the x. Put that plus c in there right away on the side the x's are on. Take the 0, plug it in for the y. Take the 1, plug it in for the x. ln of 1 we know is 0. You get your c is -1. You can plop that back in. And then you have to solve that for y because all of them will say y equals on those. And so when you're solving this thing for the y, I just did my main differential log. I did e to that equals that, and then you can handle solving that for that y, and then we're done there. Cracks in the sidewalk.